So this is a follow-up video, sort of a part two to the previous video that I posted about how to get started with finding references or examples, built examples for your detailing process. And I do want to touch on what is actually the importance of constructing details, and why do we have to put so much work into developing these details. Just thinking about other crafts and practices where you have standardized kind of solutions and you just open your drawers and you have all the technical aspects ready and at your hand, and it's one of the inefficiencies and the kind of uniqueness of our craft of being an architect, that every single time that you, or most of the time for most of us, every single time that you develop and design a building, it's sort of a prototype. It's a one of a kind project and building. So it does require us to put in that extra work of developing those details and customize them specific to the needs and requirements that we have. I often refer to detailing and construction as sort of the grammar of your building. If you look at language, it's grammar that sort of dictates the logic of how sentences, paragraphs, and texts are formed to form that cohesive whole. So if you look at a building again, it sort of has a certain aesthetic, a certain look that should be cohesive. And again, those details, they ensure that is done in a comprehensive way. And obviously you probably know the saying of the devil lies in the details, and it quite often actually does. Yeah. So the detailing part is a bit like the translation between the planning stage and the actual building stage. So your details, they will determine how things are constructed, how things are put together, so that they are literally the blueprint of how your building will be constructed on the site, not just how you envision it to look like in that kind of abstract way in your plans and renders and drawings and everything, but how is it actually executed and manufactured on a site, with knowing that on the site you have little discrepancies and tolerances, and not everything is can be done as nicely and as neatly as you can do in a CAD drawing. So there's always a bit of a consideration in that translation process happening as well. And of course the details are also translating between the different scales. As you're probably aware, that we are drawing our plans at different scales, from more like large scales of site plans, having ground plans, and we zoom in into those details. And with each of those zoom ins and each of those scales, we understand a different aspect of how our buildings are constructed. So this is a really, really important thing in our workflow of like jumping between these scales consistently and understanding that what is working on a detail scale, on maybe a 1 to 5 scale, has an impact and does also work within the bigger picture of your project, within your ground plans or 1 to 100 scales. So this is really, really important to understand, that you work across the different scales simultaneously and iteratively as well. And we have to double check that things are constantly working. So for detailing, for the constructions, of course there are a lot of technical requirements, things that need to be done in a certain way to ensure that our buildings are safe, that they are stable, that obviously that everything is holding up, that the things that we attach to each other actually hold tightly, so they're not just going to fall off at the slightest little storm that's happening. But then there's also safety requirements in terms of, as I mentioned quite often, in terms of water management, making sure that any kind of water, whether that's rainwater, snow, or it could be water vapor, condensation, humidity, all of these adverse effects that could potentially damage a construction over time are managed in a proper way, so that we can ensure that our building will last for as long as we intend them to last. So it's very much about preventing damage in that specific case. And each of the details, they are quite unique in how you solve them. So they are specific to the materials that you're using. They are specific to, of course, the construction principles, whether you have a brick construction or you have a timber construction, but also all the other layers that make up your building. So it depends on the kind of insulation that you have. It depends on the cladding, on the facade elements that you might be using. all of that. And then to make it a bit more complicated as well, all those material and product specific requirements, they also very much depend on what country and what place that you live in, because not everybody has the same, you don't always have access to the same materials or products, and so therefore they always need to be adjusted to what you have available on your site, in your place, in your country. And I stressed that before, that's really important when you look at references and at other built examples. They may be really good examples and they work really well, but maybe you do not have access to those materials, or maybe your local, the people that build your buildings, they may not have the knowledge to work with these specific solutions. So that's why that kind of localization of detailing becomes really, really important. Because once again, solving a detail on paper within your CAD drawing, that's one thing, but you always have to consider that there's going to be somebody on the site reading your plan and then constructing the building based on those plans. This is very important to understand, that a detail cannot just be looked at in its kind of isolated moment within the construction, but you have to understand the detail as part of that bigger picture. Again, that jumping between scales is becoming really, really important. So you might be able to solve, let's say, a roof detail, how the roof is meeting the facade, and then the next step you're looking at a foundation detail, having a look at how the building meets the ground, the soil. And if you don't put these details adjacent to each other and together, there might be discrepancies. So it is really, really important to look at everything holistically. That's why you quite often find these beautiful facade sections where you see every single detail together in one continuous drawing. They're really, really beautifully done, and it's really important to understand why you need to put everything into these considerations at the same time. And last but not least as well, when we're detailing, it's not just about the technical parts and the material aspects of it, but there's also aesthetical and conceptual and cultural considerations that need to be considered in that process as well. There are take a walk in your city and have a look at how the buildings are constructed. There's usually a local sort of identity. There are some cultural practices in how buildings are put together, and it's really important that we pay our respect to these practices as well, because they eventually form that identity of a place that is so important to strengthen and to value as for what it is. Yeah. So in general, details should be as simple as possible and as complex or as complicated as needed. And this is particularly to keeping in mind that people have to construct them with their hands, with tools, with machinery. Keep in mind, if you are designing details in a too complicated manner, people might not be able to execute them in the way that you actually intended them, and so they might have to come up with a compromise in that process, which would mean that maybe things are not put as neatly together as they should, so that could eventually lead to damage within your construction, maybe at the moment of construction or maybe down the line a couple of years, because they are not carefully put together. It could mean that if you're making them too complicated, you might use more materials as necessary. That means you're spending more money for your construction, but it also means that you're spending more resources, more materials, so therefore having an adverse effect on the ecological footprint of your building as well. And it can also mean that there might be issues of safety for your construction in general. So the simple solutions are quite often the most elegant solutions as well. And the way I usually approach it is that you intuitively realize there's a certain detail, maybe it's a roof to facade detail that catches your attention the most and that you're very interested in having a look at, and maybe it's also the one that's easiest to solve for you. And if you have one of them, there's it establishes a certain logic that you can then apply to all the other details as well. And that's usually a really good proof of concept if you manage to draw that continuous facade section in that with that same kind of concept, that same sort of thinking. It makes for a really cohesive project. Because again, the person who assembles your building, they are not just assembling one detail, but they're assembling the whole thing. So once they understand how to put together one part, they learn your thought process behind it, and then it'll be much easier to construct the rest of your building as well. So it's all about that kind of communication. It's about empathizing what the builders on site, how they are working, and really about bringing together all these requirements and considerations from very different dimensions and aspects of architecture. And that's I think it's a really interesting part of our work.